In this video, we're going to continue to explore the high definition template in Unity and also the tutorial so that we can have a first look and overview to the features. And we're gonna expand more on this information in other lessons. So I'm gonna continue from where I left off in the previous video, and let's go in the project settings. I wanna fix the volume here. So I'm going to go in the graphics and the default volume section, and I want to adjust the hue because I played a little bit in the previous lesson. I want to adjust this by putting this to 0 or like -2 or -3. And also saturation here, we can adjust if we want more desaturated color or we want extreme colorful scene. Okay, and then let's go with the sky. So we already saw the sky and the fog in the universal render pipeline. Now we're gonna have a look to the HD render pipeline or high definition render pipeline, but it's gonna be pretty similar. So essentially here we have a visual environment, and this is defined in the render, and we can choose between HDRI sky, physical base sky, and gradient sky. So there are always overrides, as we saw for the volumes. So there are effects that can be overridden and that can be set in many ways. So we need to figure out where these places are, where we can set up these properties so we can manage them later on as best. We talked about the anti-aliasing in the previous video. So let's have a look to HDRI. So what are HDRIs? Now, these are basically textures. These are maps. They are called environment maps, and they're used to simulate an interior, an exterior, or different scenarios. So if you have like day scene or night scenes, etc., etc. And these are they exist in every 3D software. So they can be called environment maps sometimes, or ambient, etc., etc. And if you know any 3D software, you probably know them. So this is just for the real beginners. But essentially, this is kind of a dome that is going to surround your scene. And these are used for many reasons. These are used to give an environment lining first. So they definitely used to create a really draft and base environment lining to your scene. But they can contain also like sunlight and other artificial lights. They are also used as a background for some scenes, for products and like small object or not complex scene that can be used as backgrounds and also as reflections because they can help to have a better and more realistic reflective effect on materials. So these are the three main reasons why we use HDRI, and we can say they are the base of our lining system. We can also not use them, especially if you are in interiors, but using an HDRI or an environment is always suggested. So we have three different types, and again, we are in the graphics section, in visual environment. So this is the way we can customize them or change them. So this is physically based sky is referring to the day and daylight system, and then we have HDRI, which uses a map and a gradient sky also, or we can put none. So this is where we can manage first in the default volume the visual environment, and there are other information here you can read. So this will be used if you don't have any nearby light probes or light maps. For the indirect lining, the render will go and look for the global ambient light probe that it's based on the sky, as it said right here, which is not pretty accurate, but it can be used to have, again, a general environment. So for this reason, in the visual environment override, it's important to select the ambient mode to control how the global ambient probe's lining is generated. And this global ambient lining probe is generated in two ways. We have dynamic, which basically refresh on every frame, and it's a little bit more heavy, and it's based on the current render sky. And then we have static. So the static one, it's basically baked. So we need to run a calculation, and will be generated by the volume profile, the static lining sky, and we're gonna find this into window rendering lining environment tab. This panel here, this window, we already saw this in the previous video, and we're gonna go back there. So always read everything here, and let's see here. Let's go to window, and let's go to the rendering. There you go, lighting. So this is where you can manage all the lights and all the different types of lighting assets. So this is the environment, HDRI, and right now we're using volume global, volume profile. So there you go. It's using the volume global. So we can look for this into the scene. So we can go as is suggested again from the hierarchy here in lining volumes, and we have volume global. So this particular setting is handled by this panel right here, or this volume. So it's not like in the default, but it's this one here is overriding the default, and is, you can see here, we can turn on and off. We can change the exposure as the tutorial is telling us. So we can change this, and this is going to override the default. So intensity mode, exposure, let's put this like 11, and you can see it dropped down the brightness of the sky dome. So again, back here, we can see using the volume global, volume profile, and well, that's pretty much it. And let's move on. So let's go next. I'm gonna be quick, the quickest I can here, because this is just again a tour, a panoramic view of all the things we need to take care of when we create our scenes. Later on, we create our own scene. Again, the fog, we already saw this previously. So we have two types. We have kind of a generic fog into the world, and then we have volumetric fog, which is based on a volume and cameras. And it's going to get really beautiful volumetric effects in combination with light. So this works with the light. And it's using the Froxel, which is a technique, as we can read here. So let's go next. And again, we're going to find this in the volume global. So this is handled by this and overriding the default. And just below, sorry, this is all the volume part, and below the HDRI sky we have fog and fog settings. There you go. So we can tweak this, enable, disable. We can play around with the various parameters. So to have a nice and realistic environment, you probably want to add a fog effect, and in some cases you don't have it, like with the low quality settings you don't have fog. And here we also have kind of an animation in the fog, but that's for the volumetric. So we have ambient light probe dimmer. So we have a setting to dim the ambient lining, so the influence of the global ambient probe on the fog. And then we have the fog distance, denoising mode, which is going to get rid of the noise in the render, and other stuff here. So let's try to change here, for example, the distance. So volume fog distance, if you decrease, you can see that it's gonna end real close to the camera. So this is referring to the camera, and 5 should be 5 meters. So after 5 meters, it's just gonna disappear. So we can define the intensity of the fog and how big it is. And then we have different denoising modes. And it's suggesting to use both, because if you read in the notes here, so some is lighter, some effect is lighter, some effect and less accurate, some effect is slower and more accurate. And if you use both, that's gonna produce a really smooth fog, and is gonna use both the techniques that are described here. So Gaussian and reprojection are the two, or we can use both for the best results, but also the more expensive in terms of performance. And you can test them. So here is saying that if I use reprojection, it's gonna create like ghosting effect when you move around, but I don't see any particular defect here. So anyway, we're gonna go with both as is suggested here in the tutorials tab. And here we have other settings like slice distribution uniformly, and well, just read here and you see that this is gonna like equally distribute the quality of the fog, or is gonna change it in terms of distance. And directional light improves the performance by only using the directional light. So if you want, otherwise it's gonna use like also the other lights, but it's gonna become heavier as an effect. So always read these first suggestions here. They can help you understand how the system works. And sometimes it gets really, really complex. So sometimes you probably want to stop and don't go too deep. Now this is another one, is a volumetric fog. So it's based on a volume, and it's a box-shaped area used to increase the local density of the fog. And we can find this in the, there we go. It's gonna also use a 3D texture in this case, which is kind of an animated cloud effect moving, if you can perceive it. And it's gonna be again in the hierarchy, if you look for them, in the lining, local volume fog. So if you click, you can see it, it's right there. So you can select it, you can move around. So instead of the generic fog that goes overall and in every part of the scene, this can be limited, this can be constrained into an area. And if we go into properties, there we go, that's the local volumetric fog that we can turn on and off. And as I said, is using this to intensify the mist or the foggy effect. And then we have fog distance and other parameters here. Single scattering albedo tint. So this is like where you can change the color. This is the distance, so you can see that if you increase it or decrease it. Well, if you increase it too much, you're gonna have a strange black effect. So don't increase it too much. And you can change the color if you wanna simulate, I don't know, something that is colored, some fog that is colored. And he's using also a texture here in the mask mode. So this one here is the texture. You can see it's a fractal noise sample, and as you can see, it's animated. So it's making the fog looking more alive. Next one is materials. Again, we just introduced materials in the universal render pipeline. So this is for the high definition render pipeline. And if you want to look at the material of an object, we can select it. We can look for the mask. So this is using RGBA, so red, green, and blue alpha channel mask, and it's using Metalness, ambient occlusion, and others. But anyway, before you create your own material, you probably want to study a little bit how the other materials are made. So if you can find the object here in the hierarchy as usual, or you can just select it in the scene. If you're looking for something specific and type, and that's going to isolate the object. So that's the material we are going for. And let's go to Window General and Inspector, which is the same thing of opening properties, just to refresh a little bit also the inspector. And we'll find the material at the bottom. So if you scroll down, there we go. We have a material section. It's using the brass mat. So this is a metallic material. We can definitely see that this is metallic. And all the way down here, we find all the parameters for that material. So especially if it's transparent or opaque, which shader is using, you can see is using the HDRI lit, so it's more advanced. And these are PBR, so physically based materials, so they have um, properties that can be found in nature, in real life. And then we have base map for the color, the general diffuse color. Then we have mask map, and here we have the possibility to click on the little circle and put none. So that's gonna deactivate that specific map. So you can see we have many maps. We have mask, we have the base, and then we have the normal map right here. So if we deactivate everything, it's gonna look like more flat. This is looking like a perfect mirror ball. And this is thanks to the metalness or metallic parameter. So if we now address the metallic and the smoothness, you can see how it gets like from total diffuse into total mirroring. So metallic and smoothness, it will handle the glossiness and the roughness of the material. Roughness means that it is not too shiny. The other way, the roughness, if you decrease the roughness, you are essentially increasing the glossiness. And this is the smoothness, which is kind of the same thing of the glossiness, I think. And this is a metallic effect. And then we have others. Now, PBR materials are physically based render materials. If you want to do a search, you'll find them also on the web. And if we see the most important properties are metalness and roughness or glossiness, depends on some render engine that use roughness, some use glossiness, but I think the most accurate is the roughness, which is it's everything about the light, but we're gonna check that later on as usual. Now let's proceed, and you can continue if you want to play around. I'm just gonna hit Ctrl Z. We can also use the undo history panel here to see all the changes, even for the materials. So everything you do usually is going to go in the history. Now, next one is going to be the level of details or LOT, and is suggesting us to select the round table glass, which is this cylinder right here. And if we go in the inspector, we can see the different LOTs, meaning the different quality of the model. So if you get to lot 0, you're gonna have like the best quality, meaning the best textures and the best 3D model full of details. If you go into lot 3, it's gonna be more approximate. So the closer you get, the better that table should look in terms of textures and in terms of mesh. So this is how lot work, and now we can also check them in the scene panel. So this is the material of the table, which is metal again. So you can also see how other objects are made just by going there and checking the materials. And this is the glass. So it's under the table object. And you can see this is as a material is a transparent material. It's not opaque material. So this is the first thing you would do if you want to create glass or transparent stuff. Now, glass and other transparent materials, they also use the refraction, which is basically the light going through the object by being affected by the object. And the more the object affects the light beam, the more we have refraction. So we have also an index of refraction, and every material has its own index of refraction. And also we have smoothness. So how opaque that could be or not. And then we have also the different refraction models. Now, another type of transparency is called subsurface coloring, which is not really transparency, but it's translucency. In this case, the light, it's the object, go inside the object, but doesn't leave the object on the other side. So it doesn't go through, it just stays inside and it scatters beneath the surface of that object, like a leaf. It's a perfect example. So in this case, if I look for the bamboo, this is the object that is using the material, the subsurface coloring material. And of course, we can also address this with its own parameters like thickness and other stuff. And this is a little bit more advanced usually, and also a little bit heavier than transparency. So first we have refractions. that are pretty heavy. Then we have refractions or transparency that are a little bit heavier. And then we have subsurface cutting, which is an even heavier effect. And everything is handled here. So if you look for the specific parameter, you can see here material type, subsurface coloring, and it's still considered as opaque. So it's not like total transparent, but it's in a midway situation. And then we have the masks again here. So we have subsurface mask, transmission mask again for transparency, thickness, and others. So let's continue pretty fast. Now, what is baked lining? Again, we already talked about this. Baking is essentially the process of taking some of the lights that are in the scene and not leaving them to render dynamically, but just put them in there, render, and then the baked lining will be fixed to the textures, stored into the lining information. So it's going to basically create textures using the light maps. And so again, if you're curious, you can just go forward here and see the different information. Now this image shows how the baked lining will look like. So baked indirect in this case. So let's go in the lining panel again. And here in the first scene, we have real-time lining and baked lining and mixed lining. So in the real time, you can see now this is turned off. So we are not using real-time lining. We are using a mixed lining. And this is going to be a mixture of the baked and the direct. So this is baked indirect and is using the light mapper. You can use the CPU or GPU to calculate, and you have the parameters here to calculate indirect lining and then bake it onto the objects in the scene. And this is gonna make things a little bit easier for the real-time renderer. So if it doesn't render everything, but something is already baked, that's gonna be less heavy scene. This one here is for the settings. Right now we're using high. So here you can change them. You have different light settings assets. So for the highest level, and then you have the low level, the medium level, etc., etc. So if I use this, it's going to be real-time GI, so real-time global illumination, and it's not going to use baked or mixed. So it's the heaviest situation. But for what I can say, I think the future will be like all real-time, and the lighting will be calculated just like in reality. Again, if I change this into medium, you can see that this one here instead is using baked indirect, and the samples there and pre-calculated, not real-time render. So by changing that, you're gonna change the type of rendering. Then we have probe volumes. These are type of probes that will calculate the lining based on like a space. So they distribute inside the space with a defined spacing, and they're going to calculate what is happening in terms of lining. So the placement of this is automatic. You don't need to place them. You can just change the minimum maximum probe spacing settings, and they will automatically distribute and calculate the lining. And so this is applied pre-pixel per pixel instead of per object, so it's a little bit more accurate. And these are other examples that you can see if you want, but essentially it's another way to calculate the lining internally and externally, as you can see. And there are a lot of advanced stuff in here, so I'm just gonna go forward, and there you go. So I just want to end up this lesson like this, and we still need to see some other things, so we're going to continue in the next video. Subscribe if you want to stay updated, join the channel if you want to thank us and support us creating these guides, and check out other courses and videos that we have in the channel. Thanks for watching. See you in the next.